prove that n to the third power minus n is divisible by 3 for all natural numbers greater than 1. So for this problem, we use a proof by induction. So let's first start by saying that n to the third minus n is equal to a function, f of n. And now, using induction, we just have to check for the first case, and then check for the n plus 1 case. So the first case is the natural number that's just greater than 1, or 2. And 2 to the third minus 2 is 8 minus 2, which is 6. And 6 is divisible by 3, so we know that this works. Now we just have to check for the case of f of n plus 1 by first assuming that the f of n case is true. So we'll assume that f of n is divisible by 3. And to check for the f of n plus 1 case, we'll just plug in n plus 1 anywhere we see an n into our function. So we have n plus 1 to the third minus n plus 1. And now we just have to expand this cube here. So n plus 1 multiplied by itself 3 times, and we can distribute this negative so that we have minus n minus 1. And multiplying these first two binomials together, we'd have n squared plus 2n plus 1. And now we just have to multiply it by n plus 1. So we'll distribute this n first, so that we have n to the third plus 2n squared plus n. And now distributing the 1, we have n squared plus 2n plus 1 minus n minus 1. And what you can notice right away is that we have n cubed minus n, which is the original f of n. So this here is simply f of n, which we've assumed is divisible by 3. And then we can add this 2n squared plus n squared, which is 3n squared. And then we have an n and a 2n, which makes plus 3n. And then we have plus 1 minus 1. So these each cancel out. And we're left with n cubed minus n plus 3 times n squared plus n, since we can just factor a 3 out from each of these. And notice that whatever value of n we put into this term here, it's going to be multiplied by 3, which means that it would be divisible by 3 after taking the product. So we know that this is divisible by 3, and we've assumed that this is divisible by 3. So if the f of n case works, then f of n plus 1 would work as well, because this and this are both divisible by 3. And that completes our proof by induction. And another way to know that this function, f of n is n cubed minus n, is divisible by 3 is that we can factor out an n here, so that we have n squared minus 1. And n squared minus 1 is a difference of 2 squares. So we can factor that as n plus 1 multiplied by n minus 1. And notice that for whatever n I put into this expression, I would have 3 integers in a row. So let's say I put in 8. Then I would have 8 plus 1 is 9, and 8 minus 1 is 7. And 7, 8, and 9, 3 numbers in a row, is guaranteed to have one of these numbers be divisible by 3, since every 3 numbers you end up with a number divisible by 3. And this will work with any number you put in here.